So anything I write down, you should write down on your paper. I wonder if I can make this skinnier. Guess not. Alright, so the first thing we do, after you got your name, after you got your topic, is we write out the essential question. And this is just in case you've never seen Cornell Notes before. The essential question is the big idea, what we're trying to answer by the end of the lesson. So our essential question for a relationship between sets of numbers is, how can you is you, the person writing it, classify and order rational numbers? So if you can't answer that now, that's okay because we haven't done it, but by the end of the lesson, you should be able to at least have some idea how to answer this question. Okay? Oops. And I'm going to have some idea of how to spell numbers. Okay. How can you classify and order rational numbers? Alright, so the next part is the notes. So I give you this part. Over here on the left-hand side is what you're going to do on your own. So after we take some notes, after we're all done, you're going to go back, you're going to read what you wrote, and you're going to come up with a question that is answered by the notes. Okay? And if that doesn't make sense, that's okay. We'll come back to it at the end. All right, so let's do this. Notes. Vocabulary is where we're going to start. So we're going to learn some new words. And we're just going to learn our different set names. So the first set is the biggest set we see in 7th grade, are rational numbers. And rational number is any number that you can write as a fraction. Number, that, I'll take Miss Geyer's words because she's the pre-AP teacher, so she's the smartest, that can be expressed as a fraction. Now if you write faster than me, because I'm a pretty slow writer and talker in most things, on the bottom part, or bottom right in your YouTube menu, there's like a little gear, and you can change the speed of the video. So if you set me to like 1.25 speed, this goes a little bit faster. Okay? If you can't keep up with me though, you can also pause the video, and then you can take as much time as you want. It's okay. We won't know. Alright, a number that can be expressed as a fraction, in which, and this is the extra part, and it's not as big of a deal, but it's true, so we write it, which the denominator is not 0. Because if you have a fraction with a denominator of 0, that's undefined because you can't divide by 0. So we throw this in here just so that there's no nothing to mess us up. So any number can be expressed as a fraction. All right, our next set are integers. And an integer is any positive, ooh, that's a P, positive or negative whole number. And we're going to see what whole numbers are in a second here. So any positive or negative whole number, including 0. Okay? So that's like -3, -2, -1, 0, 1, 2, 3, 4, 5, so on, so on. So anything basically that doesn't have a decimal at the end, or doesn't have an extra fraction, has to be an integer. Okay? Then our third set, whole numbers. Said we'd get to it. Here it is. And that is any positive integer, including 0. So what's the difference between these two? Well, whole numbers you would start at 0 and just gets bigger. So 0, 1, 2, 3, 4, 5. Whereas integers, it also includes all of your negative numbers. So really the big addition to integers are your negatives. Okay? So whole numbers, all your positives. And then our fourth set, which is the very first set you ever learned, which are your natural numbers. This keeps resetting itself. Natural numbers. And these are also referred to as counting numbers because we can count them. Oh, it even says that. Oops, I gave away the spoiler. So any positive integer, I should have read the notes before I started writing them. I think I'm so smart that I can cheat. But my handwriting shows that I am not very good. Any positive integer, so counting numbers, that's parentheses there. So parentheses counting numbers. And then we specify this does not include 0. Okay. So the difference between whole numbers and natural numbers basically comes down to 0. Okay. So 0 is a whole number. It is not a natural number. Because unless you were a weird kid, you did not start counting at 0. Right? You weren't in kindergarten and they gave you a bunch of ducks and you didn't say, well, the first one is the 0th duck. So they would have laughed at you. That's not what we do. Right? So natural numbers, positives, but not 0. Okay? And this is basically going to be the answer. Whoops. The answer to all the questions of the next section. So we're going to give you some numbers and you're going to say which of these sets does it belong to? Okay. So let's write our question. To which sets or sets, so there's multiple answers possible, do the following numbers belong? Alright, so our first example is -5. Okay, so if we say -5, I go back to my sets. Oh my goodness, that's no mess with me. -5. So can we express that as a fraction? Can you write the number -5 as a fraction? We say yes, we can. Because we can say -5 over 1 still equals -5. So we can say -5 is indeed a rational number. Oops, I don't have the right number. I'm just going to put rational. Okay? So then we go down our list. So we're just going to keep going down the list. We're going to see if it works. And if it says yes, we keep going. If it says no, we stop. Okay? So is -5 an integer? So we said integers includes our negative numbers. And since this is negative, this is absolutely an integer. So we keep going. So is it a whole number? Well, since whole number specifies it has to be positive, it cannot be a whole number. And if it's not a whole number, it can also, or it is not also a natural number. So our answer is just rational and integer. Okay? Then our next one, tries to throw a curveball at us, is 9/3. 9/3. So let's start with the list. So can it be expressed as a fraction? Okay, well 9/3 is a fraction, so it can definitely be expressed as a fraction, because there it is. Okay. But now where they try to trick you is these remaining 3 don't involve fractions at all, right? Because we said like -3, -2, -1, 0, 1, 2, 3. There's no fractions, there's no decimals there. So some people will see this and say, well, since it's a fraction, I must be done here. And that's the trick. Because if you think of 9/3, you say, can I simplify 9/3? And we can. So if I said, what can I divide 9 and 3 by? And you'd say, oh, I can divide both of those by 3. And that gives me 3 over 1, which is just 3. So 9/3 is equivalent to 3. So what kind of number is 3? It's still rational. Is it an integer? Well, it's positive, so it gets to be an integer. Okay. Is it a whole number? Well, it's positive. We said that already, so it gets to be a whole number. And is it positive and also not 0? And yes, it is. So it also gets to be natural or counting. Okay. So that's it. So if it's a natural number, another way to think of this, if you don't want to go top to bottom, you can also start at the bottom and be like Drake, work your way up. So if it's a natural number, it has to be a whole number, has to be an integer, has to be rational. Okay? So anytime you see that it's a counting number, it's going to be all 4. Let's do one more. So we have 0.3 repeating. Okay, 0.3 repeating. So is it a rational number? Can we express it as a fraction? And depending on how good your knowledge of fractions are, you may or may not know that 0.3 repeating is equivalent to 1/3. It's not a very good 1/3. That's a 1/3 right there. And 1/3 is definitely a fraction. So any repeating decimal, you can write as a fraction. Okay, so any decimal, repeating or terminating, gets to be rational. Okay, even though it's not a fraction, you can always write them as a fraction. You don't even need to know what the fraction is, you just need to know it is indeed a fraction of some sort. Okay, but now is it an integer? Well, since there's a decimal, it does not fit this whole number classification, so it's not an integer, and if it's not an integer, it's nothing else. So 0.3 repeating is rational only. And we're done with this. That's it. That's all numbering sets are. Okay, practice some more of this tomorrow-ish. Depending on when you watch this, time may be different. Some other day we will practice. Okay, I'm going to turn my paper over. You may still have room. I write kind of big. Okay, we're just continuing on. So in the second part of this, we talked about the sets of numbers. Now we want to compare rational numbers. So big focus, even though we talked about all the number sets, rational numbers is really where we spend most of our time. So how do we compare rational numbers? What do we do? You, not we. I would put we, because I think it's a team effort, but my notes here say you, so I'm going to stick with you. You need them being rational numbers, in the same form. What does that mean, Ellis? The same form. Oh, I have the answer here. It says all decimals or all fractions. Okay. So then the question becomes, do I want decimals or do I want fractions? And that's sort of a judgment call on your part. But we're going to see some examples. And we'll hopefully help you with that. So a couple friendly reminders. Remember, pro tip, to change a fraction to a decimal, practice it all year. Hopefully, change a fraction, and hopefully you're screaming it at your phone or computer. How do I go from fraction to a decimal? That's right. We use TIBO. And if you weren't with us last year, TIBO means top, in, bottom, out. And this is just a way of dividing fractions. So anytime you have a fraction, let's say 1/3, that's what we were talking about earlier. If you wanted to make that a decimal, you would take the top number, you would put it inside the division house. You would take the bottom number and put it on the outside of the division house. Okay, that's how you go from fraction to a decimal. And then you just have to know how to divide. Okay, how about the other way around? So if we wanted fractions, if we want to turn everything into a fraction, we would need a common denominator. So to get a common denominator, this is a lot of writing. It's very little numbers. Why did I agree to this? To get a common denominator, find a common multiple. And something to note here is we don't say least common multiple. I mean, you always could, sometimes preferable, but not necessary. You just need some common multiple. Okay? And then a couple symbols we use when we compare an order. You may remember these as, I'll put these off to the side, you don't have to write them. Let's go yellow. We have Pac-Man, who eats the bigger number, right? Or there's the alligator with alligator teeth. I never learned how to draw an alligator properly, but I always try because that's what I do. I'm a trier. Look at this. Look at this alligator. Give him some scales. Give him an eyeball so you know what was going on up here. This is nose, right? Maybe he needs a little bit bigger. No, this is getting worse. This is my alligator. Okay, alligator eats a bigger number. Pac-Man eats a bigger number. You can use that to remember less than, greater than. But since we're getting older, we need some words to go with that. So let's give them some names. So our first symbol means less than. Our second one is, you guessed it, greater than. And our last one, an old friend of ours, equal to. Okay? And if you forget what the symbols mean, because that happens, right? We don't see these that often in 7th grade. If you look at a problem, like let's say we have 2, some symbol 3, right? 2 loves 3, okay? You would just read it and think logically, what's true? We say 2 is what to 3? And hopefully you say, it's less than. So this symbol has to be less than, right? There you go. Okay. So that's really the end of the notes. Then we just got a couple of examples to do. So our first example says, which one is bigger? Which one is bigger? 3/4 or 4/5? Which number is bigger? So we're going to go with our common denominator here. So we have 4 and 5. So we can find ourselves a common multiple. 2 different ways we can do this. So one of my notes says find common denominator. Okay, that's what I said. This guy assumes you can do this without any help. But my kids might need help, because my kids like to write more. So a couple ways to do this. Our denominators are 4 and 5. So if I wrote those down and I just listed out my multiples of 4, 8, 12, 16, 20, 24, so on. My multiples of 5, 10, 15, 20. And I can keep going, but oh, look at this. Look. These are the same. So our common denominator, we can say, is 20. So we can rewrite both these fractions as something over 20. And then we just say, what did we multiply 4 by to get to 20? Well, that would be times 5. So 3 times 5, same, anything we do at the bottom, do the top. So 3 times 5 is 15. Okay, 15 over 20. Come over here, do the same thing. So 5 times what is 20? That's 4. And then 4 times 4 is 16. Now once we do this, this is the work, and then the problem's really easy. We say, what's bigger, 15/20ths or 16/20ths? Well, 16 is more than 15, and since they're the same denominator, we can compare that way. So 15/20ths is less than 16/20ths, right? Another way to find common denominators, which would give you the same answer here, because this is a nice problem, is you can always take, I'm kind of making a mess, don't feel like you have to circle these. You can take the two denominators and multiply them together. So in this case, 4 times 5 is 20. And this will always give you some common denominator. Not necessarily, what was I saying? Not necessarily the least common denominator, but it'll give you a common denominator. In this case, it was the same. Okay. One more. I ran out of room. I'm going to go to the next page. You probably have room, I hope. So last one, what if we had 3 numbers? Ooh, fancy. Okay, so 7/10, 0.6. I'm going way over time. Miss Geyer's going to freak out at me. I'm sorry, Miss Geyer. I'm slow. Order from least to greatest. I want to go from least to greatest. Or, if this problem was written out for me, I would rewrite it as L to G, so I don't forget later on. So anytime you have more than 2 numbers, generally you want to change everything to a decimal, especially in this case where 2 of the numbers are already decimals. So all we really need to do is, what is 7/10 as a decimal? So I'm going to use TIBO, top in, bottom out. 10 cannot go into 7. It goes into it 0 times. So I'm going to add a decimal, and another 0. And I'm going to say 10 goes into 70 7 times. And that works out nicely for us. So 7/10 is 0.7. I'm going to leave it like that for now. I'm going to bring this one down. That's already decimal, 0.6 and 0.72. I'm even going to drop the repeating part here for now. So I have 2 decimal places and 1 decimal place on these other ones. So I'm going to put in a second decimal place value. So since there's no value, it's just 0. And now I can compare these 3. So which is the least of these 3 numbers? 0.70, 0.60, or 0.72? Hopefully you'd see that's 0.60 or 0.6, because you always want to write your answer the same way it was given to you, no matter what work you did. The next biggest, either 70 or 72, 70, so 7/10, sorry. And then our biggest number was our 0.72 repeating. Okie dokie. And that's it. That's the whole lesson. Which took a little bit longer than I thought, but whatever. So now what you need to do, 2 things. One, on the bottom is a little summary, and you're going to write about what you did. So you'd be like, oh, I did notes on how to determine sets of numbers and how to order numbers, and you get 100. And then you come back up here, and you take like each section. Like, what question could we write here that's answered by all this? Which isn't too hard. You'd be like, well, what are those sets of numbers? And here they are, okay? And then the examples, I don't know if you need a question for the examples, but I guess your question would be like, what are some examples of this? And then on the back, the second part, when we talk about comparing rational numbers, your question would be, how do we compare rational numbers? And then you're done, and then you got 100. It's a good job, and good night.